Hey, I'm Jordan, Director of Operations for Integration Technologies. Thanks for joining me as we talk about the principles of automation. Automation has been a pretty hot topic for the last couple of years, but for many people it's still unclear how spending time building scripts instead of fixing problems is better for them in the long run. The gist of it is you spend a little bit of time now, and you can save a lot of time later. For example, if you have a bunch of technicians running around and installing software, errors are bound to happen. It's human nature to make mistakes, and we're not going to be able to fix that. Automation, however, can reduce these errors, which saves time during the actual installs because you're running into less problems, and also saving time in the future by preventing the unintended consequences of misconfigured software. I think we've all been in situations where somebody installs a piece of software and everything seems to go okay, and a month later or a few weeks later, the client calls back and something goofy is just happening because a checkbox was missed. Using automation avoids issues like this where small little things might go unnoticed during the install, but are going to prevent or cause a bunch of problems down the road. Automation makes sure that those small little things don't get missed. Automating tedious tasks also saves time by eliminating the number of clicks required. So, if you have a setup that requires a technician to do 50 different things, one, they're going to be bored doing it, and two, they're probably going to miss stuff, but three, it just takes time to click that many times. Writing a script to do it can usually click faster, so you're saving time in a lot of different ways. Training time is also reduced as you can have people who know how to run the automation and know how to run the script and know the gist of how the software works, but don't need to know where every single menu is, and you don't need to write these long, extensive how-tos on how to configure every option. The main goal of automation is to drive efficiency, and standardization equals efficiency. If something is automated, it's going to be inherently standardized because automation will always do the same thing each time. This means your outcome will be the same. Standardization is the key to efficiency because if things are similar in every location, your technicians automatically know how it's set up and know how to troubleshoot it. And best of all, standardization will drive future automation. For automation to be successful, you need to have a predictable starting point and to get to a predictable outcome. Standardization is how you get that predictable starting point. So by doing small automations, you start standardizing and you can build bigger automations and bigger automations. And over time, you have this huge amount of efficiency because you've built up these standards. But most of all, automation is just super fun. I mean that. It's cool to be able to take a task that was boring and unpleasant and turning it into something automated that you never need to worry about again. So give it a try. All right, so let's talk about levels of automation. Automation is based on the premise of having a predictable starting point, taking standard steps, and achieving a predictable and desired outcome. To do this, you have to test to make sure that your starting point is actually what you believe it is. If your starting point is different, your outcome is going to be different and probably less desirable. Automation seems like a really big undertaking, but we're in luck. There's lots of ways to automate things and lots of levels of automation to implement along the way. This means that you can start out slow and over time build up. When you first start automating tasks, you need to ensure that things actually work the way you believe they do. This is the no automation phase. No automation has the pros of having a lot of granularity. You can test things as you go. There's not a lot of impact if stuff goes wrong because it's not happening to everything all at once. The difference is there's a lot more room for errors. This is what we want to get away from long term, but it is a good place to start. Um, Once you've done the manual setups on a handful of devices or on different portions of the network, you can move to the partially automated phase. Partially automated is the best place to be when you're doing widespread deploys. You don't want to be manually installing everything, but you don't want it to be going blindly yet, especially on a new client network. The pros of this are it's faster than a manual install. There's fewer errors because you're using things like templates and you're using things like profiles to ensure that settings are what you want them to be. And settings are consistently applied at that point. The cons are things can still be missed because it's not fully automated. It still relies on a person understanding that something exists, but you can still catch a lot of those towards the very end when you move to the fully automated stage. And it's possible that you can get some of the templates wrong. So you want to make sure you really get those corrected during the no automation sections. Once you've had an application mostly rolled out, that's when you want to move to the fully automated stage. Fully automated means that when a device shows up without you intervening, it gets whatever software you wanted installed and the configuration just kind of happens. This is where we want to end up on pretty much every network. Is you want a new device to be added, then the software that you expect to be there get installed automatically. Things like your agent or OpenDNS or whatever other applications you feel like using. The fully automated is your maintenance phase, basically. Make sure that you always don't have to have your eyes on the network, that you're letting a computer do that for you and paying attention. At an MSP, knowing when to leverage automation in a client's onboarding is key. Wanting to turn on all of your automation from day one is really enticing, but it can be a bad idea. Before implementing automation, you want to make sure you test every part of your stack in the client's network individually. This gives you the ability to make sure that everything that you believe to be true is true, and to make sure that as you're implementing stuff like an antivirus or patching, that you're not going to break a lot of stuff along the way. Once you test everything on a few systems, then go ahead and enable it for the rest, and then automate future additions. So the idea is that if you have a patching policy, for example, go ahead and apply that policy to one machine and get everything up to date and make sure that it works and doesn't break anything, and then apply it on a handful of more machines, and then just mass roll it out and turn it on permanently for everything that gets added to the network, because at that point it's fairly safe that if it gets added and it hadn't broken anything yet, it probably won't break anything major. Implementing things one at a time, so different portions of your stack one at a time, gives you the ability to really pinpoint when something goes wrong. So if you start up on a new network and on day one you turn on your antivirus, your patching, you turn on your maintenance, you turn on every other automation that you have available, and something breaks, you have a really hard time figuring it out. So if you do step by step and you go one at a time, or maybe even two at a time, if something does break, you have the ability to remediate that really quickly because there hasn't been that many things that have changed. Onboarding is when you're making your initial impression, especially for your team. Up until that point, the client has had interaction with probably with your salespeople, maybe a sales engineer, but they haven't really got to know you as a company that well yet. So you don't want to go and screw all that up by throwing in all of your automation and breaking their network. It's the opposite of what they're probably paying you for. Great. Now we know why to automate things and we know when to implement some automation into client networks. But how do we get there? What is the process of picking things to automate? So let's talk a little bit about that. I like to use a 6-step process when trying to figure out what to automate next and get it automated. The first step is obviously pick something. Figure out something that needs to be automated, something that'll get you a good return, and you want to plan it, you want to write it down, figure out how it should actually happen. You need to actually build the scripts or whatever tool you're using to automate it and get that set up. You need to test it a bunch, obviously. You're going to want to document it so other people know how it works, and eventually you want to deploy it. That's the good part, but you have to go through each one of these steps kind of to have any real success at automating. Earlier, we talked about how standardization drives automation. This is a great example of why that is true. Using your RMM platform to standardize the delivery of alerts, then using a tool like BrightGauge to identify reoccurrence is a great way to target things that will have a high return on investment once a fix for them is automated. Keep in mind that as your organization grows, the return on investment from automation increases. The more systems you have, the more time you will need to spend maintaining them unless you automate tasks. Keep track of what you are spending your time on and find ways to fully or partially automate those tasks, either to save time or to make them more standardized. Picking the right things to automate is important if you want to get the most bang for your buck. Start slow, pick stuff to refine your automation process, and then build off of those. You want to pick tasks that are simple but tedious because, one, people don't want to do them anyway, so you get a lot of return on that. And two, simple tasks tend to be easier to automate. You want to pick tasks that have lots of details that people are likely to mess up because, again, your savings comes from fewer mistakes. And you want to pick tasks that are important to get done but get missed because they seem like maybe they're unimportant, or at least in the moment, they don't seem like the most critical thing to do. Long term, usually the result of not doing them is really bad, though, so automating them is a good choice. As eager as you might be to get started on automating things, planning it is really important. Don't try to wing it. Proper planning is going to lead to your best results. If you can't do a task manually, you're not going to be able to automate it. So make sure that you know how to do what you're doing manually and make sure those steps are documented. You need clear rules for automation to work properly. There's not a lot of room for gray areas. Scripts are very, very, very logical. They're going to do exactly what you tell them each time and generally aren't going to deviate much from that unless something really weird happens while the script is running. You want to write it down. So even if you think you know how something is done, document it. Um, the upside to this is even if you never get around to actually automating it, or you run into something along the way that says, hey, I can't automate this, it's now documented, so at least other people now know how to do it the same way you do, and you're working towards that standardization goal. And make sure that the thing you're trying to do is actually conducive to automating. A lot of tools just don't have a way to automate them. If they're purely GUI based and there's no command line interface and there's no way to interact with PowerShell, you're not going to be able to automate a lot of that stuff really effectively. So don't bang your head against the wall. Just make sure the thing you're trying to do has the ability to automate. And when you're making tool selections in the future, you're looking for ways to do things, keep that in mind. Choose tools that do have a command line interface, or tools that do integrate with PowerShell, or that have some type of automation features built in. Long term, this is how you're going to be able to build up a stack that allows for automation and makes you efficient. And document things as you go along. A lot of times you're going to be working on projects like this for a while, so trying to get it all done at the very end is rough, especially if you have to stop halfway through and a couple days go by or a couple weeks go by and you forget what you were working on or forget where you left off. Or if you need to hand off the project to somebody else, documenting along the way helps out with that. You can get those notes down, somebody else can jump in and take over the project if they need to. As you get started automating, there are a few rules to maybe follow. One, learning multiple things at once is hard, so don't try to learn a new scripting or programming language while also trying to figure out how a task can be automated. It's hard enough to do either of those things. So if you're going to pick something new to automate, do it in a methodology that you already kind of know. You don't have to be an expert in it, but at least have a general understanding of what's available in it. For example, if you're very, very, very well versed in PowerShell, but you've never used Automation Manager, or you've never used, I don't know, any other scripting language, stick with PowerShell while you're doing the new task, unless there's a really good reason not to. Or pick a different task and learn the new scripting language and then come back to it. You want to avoid running into a situation where you don't know if your poor scripting is the problem or if the task is actually just broken. So keeping those kinds of things separated is useful. Before you start automating, also double check to make sure that your existing tools don't already do it. This is really crucial if you've had a to-do list for a while or you keep a running log of things you want to automate. Over time, I've definitely done this where I come back 3, 6, 9 months later and a tool that I've been using for a while has had an update and now does the thing I want. Had I not checked into it, I probably would have wasted a lot of time, and I think I've definitely done that in the past where I've written my script and then I go to implement it and I'm like, hey, there's this thing here that already does this, and my time was wasted. Oftentimes, integrated things are better, so just double check on that before you get going. When you start automating large tasks, break it up into small pieces. If you go through and you program out this really long piece of automation and you don't do testing along the way or you don't break it up, you're going to get overwhelmed at times. So to keep yourself from giving up on it halfway through or just going and putting in a lot of effort for something that doesn't work, break it up into smaller tasks and test each one of those tasks. As you go along, test each of the pieces, and as you build more and more pieces, start testing them together. Oftentimes what you'll find is that if you break it up into pieces, you might run into a situation where you can't resolve one of those pieces and nothing else after that will matter. So it's important to really understand where you are and what you're trying to accomplish, and breaking those tasks up means that you're not going to get too heavily invested in it before hitting a wall that maybe you can't get through. It also means that other people can help you. So if you know you're going to do pieces 1 through 5, somebody else can do parts 5 through 10 or 6 through 10. And at the end, you can combine them and you can put them together and you'll have a really big working thing. And you want to make sure you have adequate logging. I can't emphasize this enough. Once automations are in place, people need to be able to troubleshoot them when they don't work. And the only way to really do that is through logging. So when I write scripts, one of the things I try to do is make it very verbose. I like to log when each step kicks off via timestamp. Nearly every one of my scripts has the same logging methodology, so my techs know where things are. They know what files to look for. As a standard within the company, we all follow that. That way, any automation process that's running, it's innate in where to troubleshoot it. As I'm building the script, it has to be pretty verbose so I can see exactly what's going on and when, and do benchmarking so I can see how long different steps take. But before I release it, I comment out a lot of the logging just to leave a very user-friendly log at the end. I don't need my techs overwhelmed with 10 pages of logs. I just need them to see steps 1 through 7 completed properly at these times, or they can see where it stopped off, and if they need to, they can turn on a more verbose version of the logs via uncommenting the script and running it manually, or something along those lines. You can build in a switch to do it. There's all kinds of ways around that. But the idea is that you want it already built in. Otherwise, down the line, when they're trying to troubleshoot something, they're also going to then have to start building in logging to a script. And usually it's just easier to do that when you're building the script itself. So build in very verbose logging and then tune it out so you have a very user-friendly thing, but with the verbose version available if they need it. Testing. I've joked in the past that testing is for people who lack confidence in their skill, but the reality is we need to test things thoroughly. You want to do your testing in different environments with different permissions and different configurations, because in a managed service provider, we deal with very, very large number of environments. We don't really have absolute control most of the time of where these things are going to run, so the best we can do is test. Test each of the pieces, as I mentioned before, and test the whole, and test after every time you make a change. I've seen a lot of people, once they have a nice script running, they want to make small little tweaks to it, and they think, oh, it's no big deal, I'm just making this one little change, and they don't test it properly. The thing with automation is it's built on dependencies. So if you make a little change, it's very likely that it can impact the rest of your script. So make sure you're testing after every change. Even the smallest stuff. There's times where I've just added lines to log different things or turn off logging. Make sure you're testing it. Any missed character could cause the script to fail. Any little change could really ruin a good tool. If your script has dependencies, so you know you need specific things to exist, make your script check for those. It'll help, because what you don't want to end up with is a script that's failing for a random reason when you know what the reason was. If you need a file to be present to run, make the script just check for the file, and if it doesn't exist, write an error that says this file does not exist. Don't allow the script to just fail because the file doesn't exist. It'll save you and your team a lot of headaches and time if you're being more proactive about looking for these things. Just don't allow the error to be random when you know it can happen. As I was saying before, you really want to focus on not allowing errors to exist if they're preventable. Errors in the script should always be unknowns. What I mean by this is not that an error shouldn't occur in your logs, but the script itself should not generate an error when running. Usually, if you're running a script and an error occurs, it's going to be a result of a dependency not being present, like we mentioned, but also maybe just a command being wrong or something just unique about the operating system that isn't allowing the function that you want it to work. You don't want it to fail for something that you know could happen. For example, if your script works on Windows 10, but you know it doesn't work in Windows XP because PowerShell version is wrong, or there's just some dependency that doesn't exist in Windows XP that you need, make it check your Windows version first. By doing this, you can write a log that says, hey, my script is running on Windows XP, this isn't going to work, have a great day, versus your tech having to see a whole bunch of red pop up or a bunch of errors pop up and try to decipher why all of a sudden it's not working. This is a lot easier and takes a lot less time than trying to train every person in your company forever to know that, hey, this doesn't work on Windows XP, don't troubleshoot it. You also don't want your team to get used to seeing errors as a common thing. If they start seeing errors, they're going to forget which ones are okay to see and which ones are bad to see, and they're just going to assume that they're all okay to see. So you're going to end up with people going, I don't know why this isn't working, and you're going to come back and you're going to say, well, the error says, and they're going to say, oh, I thought that was one of the acceptable errors. Using tools like filters in Central or any other RMM is a good way to also kind of limit where these things run. Don't just set your scripts to run on everything all the time. Limit where they're running to where they're supposed to be running. This is a way to avoid problems, but you should still build in some of the checks in the script to help just in case something goes wrong. Make sure you document it. I can't express this enough. Automation is great. It'll fix lots of problems, it'll save lots of time, but when it breaks, people will have no idea how to troubleshoot it unless you document it. And then you, the person who's writing all the automation, are going to have a whole bunch of tickets to work on trying to figure out why the automation broke. You don't have to make it really fancy. It just needs to explain kind of what's supposed to happen and what needs to exist for that to happen in a way people can understand, and mostly how to start troubleshooting it. Keep your documentation relatively simple. If it's really long and complex and there's a lot of things and they have to read 20 pages of documentation just to start troubleshooting, people just won't do it. Put it in a place that people can get to it and consistently put it in the same place. That way people know it's there and they can depend on it being there, and then they'll start checking for it. If you don't do this, people aren't going to read it. And be consistent in keeping documentation. The trick to a lot of this, and this goes for any documentation, not just documentation about automation, but if people believe it exists, they'll go look for it. And if it's something that's very rarely documented, they just won't look for it. So even if you document 1 or 2 scripts, but the other 70 don't have documentation, they won't look for the 1 or 2 because they don't believe it exists. And getting anything documented is better than nothing. Jot things down, evolve the documentation over time, just like you do with your script, and just make sure that there's enough information so people either know who to ask more questions to or get them started. And hopefully, as people go along and troubleshoot, they add more notes to your documentation. How you decide to deploy a script, it really varies depending on the intent of the script. If it's just a tool that you expect someone to run when a problem comes up, like a troubleshooting tool or something that collects information for them, then you need to design it in a bit more interactive way. You can't expect someone to just double-click on a script, see nothing happen, wait a random interval of time, and then go look for a log. That would be a little silly. So you want to make it output a result or have something up on the screen indicating that it's still running, or an indicator that it completed even. You can't just let people kind of run blind. You also need to take into consideration things like if it's a nightly or a weekly maintenance script whose intent is to just sit in the background and keep running, that you're going to need to, over time, as new versions of Windows are released or new versions of PowerShell are released, to go and maintain that script. Otherwise, you're going to all of a sudden one day come in and have 1,000 errors out there, or you're going to get a really weird, unexpected result. You can avoid some of this stuff by building in dependencies, like we mentioned, so have the script check for things where you know it works, but you should have a maintenance schedule kind of set up for your scripts. It could be annual, it could be every 6 months, it could be something, but make sure that whatever you're doing has a set maintenance life. Anything that is self-healing, so X broke, so do Y, you need to be a little more safe. Self-heals in their very nature are designed to run when something is broken or in a state that you don't want it in. This means that you need to be cautious with proceeding. I know a lot of people are very gung-ho about doing things like just restarting services and things along those lines, but you really have to think about, why did this fail, and will doing this self-heal make the problem worse or better? If it's a coin toss and it could make it worse, maybe don't do a self-heal, maybe make it an alert, or maybe make it a diagnostic step to just speed up whatever the next steps the tech have to take is. Don't automatically assume that self-healing is the best route versus self-gathering of information. But really think about why you're deploying these scripts and design them accordingly. And they'll make them better for everybody to use, and they'll be used more consistently if that's the case. All right, guys. We've gone through why we should automate and how we should automate. So let's kind of go through an example together. All right, for the example, I picked something a little simple. Basically, one of the issues we ran into when using ConnectWise Manage is the email connector from time to time would get stalled. Now, this was a major problem because when this happened, tickets just wouldn't come in. They would sit in the mailbox and they would just kind of sit there and exist, and we wouldn't know that a problem was happening. And if it only happened once or twice, it wouldn't have been a big deal, but it happened kind of regularly. So we needed to come up with a way to look into this without having to depend on one of our coordinators just saying, hey, we haven't gotten tickets in the last couple of hours. Is there something wrong? Problems like this are good things to automate. They have high impact, they happen semi-regularly, and they're pretty easy to kind of fix. So in this case, the example is going to be a way to automate a notification or automate checking on something or getting the status of something versus actually fixing a problem. But it's a good place to start and a good use case for automation. So step one of all of this is to plan it. We need to understand what needs to happen in the automation, and we need to write it down. Otherwise, we're not going to be very good at scripting it. So let's go through the plan of how to check this. First, we need to connect to an Office 365 mailbox because we use Office 365. We need to determine if there's any messages in the mailbox that have not been moved to the process folder. If an email was moved to the process folder, it means it worked. So we're only looking for things in the inbox. We also have to understand that there's going to be a likelihood of false alarms. If this check runs at the exact same time an email comes in, but before ConnectWise has a chance to move that email, we don't want to get an alert. So we want to set up for a buffer that says, hey, maybe if there's 2 emails, it's okay, but if there's anything more than 2, there's a problem. And you'll need to adjust this based on the number of tickets you tend to receive and the email connector you're using and things like that. We need to make sure that the results are visible. So once this runs, we need a way for our tool to alert us, or we need a way to know what happened. So we need to make sure the results go to a log. And we need to do this for all of our email connectors, not just one. So we need to repeat the same steps within the script for each available mailbox. And we want to generate a notification if the conditions that we set above are met. Notifications in situations like this, for us, we use our RMM tool to read the log file and look for keywords like failed or error or whatever we want it to say. Or we also look for the lack of words. So if it doesn't say successfully ran 0 messages found, then set off an alert. That way we know something is weird. Once your plan is all set, you can start scripting things. For me, I'm very familiar with PowerShell, and it's an Office 365 integration, so using PowerShell is a pretty natural step, so that is what we used. Do whatever you're comfortable with, and whatever tool is most conducive to doing the task you want. Generally speaking, Automation Manager or PowerShell, they're going to be the best tools in the Microsoft world. Microsoft wants you using PowerShell. It's great to learn it. And that's kind of like what the code looks like for our script. As you can see, we throw errors, we log to files. We're generally trying to get information out there that needs to be present for us to alert and to give people a heads up when they start troubleshooting. Once your script is all done, you can go ahead and set up your RMM to do the monitoring however you see fit. We're not going to go into this video because it would be very tool specific. But let's go into a couple of more examples of how automation can kind of change how something works. Ransomware detection using FSRM. This is a great example of a tedious process to kind of implement that can be highly automated and make your life a whole lot easier. Tasks like this are ideal because they're really important. They have a very high ROI, and they're also a pain to implement because there's so many manual steps to go along with it. And not only do you have to implement it, you need to maintain it over time with the same level of tediousness. The manual to-do list is pretty extensive. You have to install roles on servers. You need to identify which servers this should be installed on. You need to enable the tools. You need to set exclusions. You need to add the proper filters. You need to keep all of this stuff updated as it changes. And you need to audit it regularly to make sure it never got disabled by somebody who was trying to install a piece of software and couldn't figure out how this works. You need to monitor the logs manually for alerts. That way you know when something breaks. Doing this for every new client as you onboard them is doable, but it's a pain, and making sure that it stays up to date for all your existing clients, especially as you grow, becomes very, very, very hard. Automating it, however, fixes a lot of this stuff. You'll still need to audit because you need to audit, but you can tie that into your QBR process or whatever process you have in place for auditing your client networks to make sure everything else is working properly. But you'll be able to convert that long to-do list into a handful of scripts, and using your RMM, you can use filters or rules to implement and keep these things up to date. For us, we also use a custom service in N-central to monitor the logs and services to make sure everything's running as we expect and to let us know when something goes wrong. These kinds of things are highly prone to error when you do them manually as well. Because you have to set exclusions, even typos can ruin the whole thing. So you want to remove as much of that probability of failure as you can, and automating is the easiest way to do that. Another good example is implementing OpenDNS Umbrella Client on your endpoints. This can go for a lot of applications, but I like OpenDNS, so I figure I'd use it as the example. OpenDNS is great if you're using it as a DNS forwarder on your servers. It doesn't really help protect laptops once they leave the network, so using the Umbrella Client is important. The issue with that, however, is making sure it keeps running all the time. If the Umbrella Client gets uninstalled, which is the case sometimes for some of our clients who have to be administrators when they're on the road, we need a way to make sure this keeps working. Normally, without automation, we'd have to install it, kind of just hope it's there, and then reinstall it once we realize the machine is now infected and that the client uninstalled it, With an automated method, we can, one, deploy it quicker, so you can use automation to deploy the client, but you can also set up a monitor to make sure it's always running. With all that spare time, I then go and relax and watch The Office because it's one of my favorite TV shows. I suggest you do the same, and you can do that instead of cleaning up all the malware infections, so it's pretty sweet. And with that, we're at the end of our presentation. I hope what we talked about was of value to you, and you now have a handful of guidelines to go by as you start automating tasks. And I hope that whatever you end up with is pretty cool. And if you do come up with something really cool, I hope you find me on LinkedIn and share it. I'm always interested in learning what people are doing, and always happy to help if you have any questions. So add me on LinkedIn, follow me, send me a message, whatever. Have a great day, everyone.